Hi everybody, this is Jim Corkins, and we are continuing on with kinematics, and we're going to move into two-dimensional kinematics. But before we do that, I would like to review vectors with you. All right, so if you haven't done the reading, please do so. Those readings are indicated in Canvas, okay? Now, we have gone over vectors already and what they represent. Okay, so we did that back in kinematics with one-dimensional vectors, and with two-dimensional vectors, there's a few things that we have to remember. Is that we're still going to be adding vectors tip to tail, just like we were doing in one dimension, but now we're just doing it in two dimensions. And then the resultant vector would be where you began versus and compared to where you ended. We will also need to know the Pythagorean's theorem, and we will need to know a little bit of trigonometry as far as getting an angle between two vectors using the tangent of theta. All right, but let's just start out with doing the addition of vectors. Okay. Now the basics of vector addition, just like you remember from one-dimensional motion, is you take the tip of one vector and you put it to the tail of another vector. So for example, if you wanted to add A to B or B to A, you would take the tip of one vector and add it to the tail of the other vector. Now the resultant vector goes from where you started to where you ended. So that's a resultant vector, like a displacement vector. Okay. All right. So let's try it out. Let's go ahead and we're going to do a little run through and review vector addition in one dimension, in two dimensions. Okay. I'm going to go over to my PowerPoint and turn it to presentation mode. So let's try this. Okay. Suppose you had two vectors, vector P and vector Q, and you need to create a new vector called vector R, which is the resultant of vector P plus Q. Which choice, 1, 2, 3, or 4, will reflect the resultant vector R? Please take a moment and try this on your own. Draw the vectors and try to take vector P and add it to vector Q, or vector Q plus P, tip to tail, and then the resultant vector will go the end of the very beginning first vector to the tip of the other vector. Pause the video now. All right, so moving right along, if you want to add vector P plus Q, you're going to take Q and add it to P. Then the resultant vector goes from start to finish. So you take the tip of one vector and add it to the tail of the other, and then you have this blue area, and then the overall resultant vector goes from where you started to where you ended. It doesn't matter the order in which you do it with vector addition. So if you started with taking P and putting it to the tail of Q, then you would get the same resultant vector. So the correct answer is number 2. Okay? Let's try another one. Let's take 2 P vectors and add it to Q vector, or take the Q vector and add it to 2 of the P vectors. So the resultant vector will be the addition of 2 P vectors plus Q. Which choice, 1, 2, 3, or 4, will result with this R vector? Pause the video now. Okay, so we're going to take the Q vector and we're going to add it to the P vector, and then we're going to add another P vector. The resultant vector goes from where you started, went to the left, then we went down to the right, down to the right. So the overall resultant vector goes from where you started to where you ended. Okay? Again, it doesn't matter the order in which you do it. You could take the q vector and add it to the p vectors. It would result with r. And number 1 would be the correct option. Okay? So that is vector addition in 2 dimensions. Also where you take a scalar and multiply it by one of the vectors. So, and then you add it to another vector. Let's talk about vector subtraction. Okay? Vector subtraction in 2 dimensions is this. Suppose you're given A and B. What you're going to do, and you had to get, and your overall goal is to take A minus B. Well, if positive B is pointing down to the right, negative B will be pointing up to the left. So you got to take that B vector and reverse it, basically take the tip of this off and put it on the other side. So you reverse that B just kind of like you do here, and that is now negative B. Now you do vector addition, okay? And incidentally, A minus B does not equal to negative A plus B, okay? So with vector subtraction, it does matter the order in which you do it. However, if you take the one vector you're asked to reverse and then you reverse it like this, now when you add A to negative B plus A is also the same vector. Okay? You'll see in a second. So let's try this out with another problem. So same vectors, P and Q, and you got to get R vector. However, R is equal to P and minus Q. So what you're supposed to do is reverse that Q vector and then add it to the P vector. In this case, which one of these choices will reflect the P minus Q? 1, 2, 3, or 4. Try it out. Draw those 2 vectors, reverse the Q vector, and then add them together and try it on your own. Pause the video now. Okay, we're back. So you take that P vector and add it, so you can add it to the negative Q vector. So Q is pointing to the left. We're going to reverse it so it's pointed to the right. Now you started here, you walk down to the right, walk to the right, you ended here, so the resultant vector goes from the start to the finish. Notice that as long as I'm using the negative Q vector, negative Q plus P is equal to P minus Q. Okay, they end up with the same resultant vector. So 4 is the correct option. All right. Now let's try the second one that we did before, where we have 2P minus Q. So you're going to take 2P vectors, add them together, and then add it to the negative Q vector. So again, you're going to have to reverse that Q vector, and then you're going to either add that negative Q vector to 2P vectors, or take 2P vectors and add it to the negative Q vector. So which choice, 1, 2, 3, or 4, reflects R? Try it out, draw those vectors. Pause the video now. Okay, we're back. So, going to take 2 of those P vectors, add them together, and then we're going to add them to the negative Q vector. The resultant of those 2 P vectors added to the negative Q vector, you started here, you walk down to the right, walk down to the right, then walk to the right. The overall resultant vector goes from start to finish. Okay, again, if we took the negative Q vector and added that vector to the 2P vectors, you would get the same resultant vector. Okay, as long as you're adding a negative Q to 2P's. So the correct answer is 3. Okay. Now, when you do the addition of 2 vectors, okay, when you add them together in 2 dimensions, what you have to do is you have to take those x direction components of the vector and separate it out from the y direction components. So this f vector is going to the right. So you take that right vector component and bring it to the bottom. And then you're going to add that right vector component to the up component of the f1 vector. When you add those two vectors together, you get f1. The x direction component plus the y direction component is equal to the overall resultant vector f. Now, if you do that for f2, you take the x direction component and add it to the y direction component. You take f2. Now, to get the overall resultant vector of f1 plus f2, we're going to take those two x direction components and add them together, and we're going to take the two y components and add them together. Then the resultant vector is the same vector of f1 plus f2. Now, if you wanted to get the overall length as far as a number, you have to use Pythagorean's theorem, which is going to be c squared equals a squared plus b squared. So c is going to be equal to the square root of this fx vector, which is the overall addition of those two vectors, plus the y vectors squared, right? And then the resultant vector would just be, since theta, we're calling theta right here, the opposite of theta is right here, divided by the adjacent portion. You get that right here. So tangent of theta is equal to opposite over adjacent. And then if you inverse that negative tangent to the -1, then you could compute theta. Okay? Now I've made some exercises for us. Okay? And we're going to do two exercises that is similar to your tutorial. And then what we'll do is we'll do another exercise as far as the addition of vectors in 3 dimensions. Okay? So, well, here is our problem. What we're going to do is we're going to add these two vectors together, J and P. So you're supposed to first, the rules say it shows an equation and you're supposed to try to find the missing third vector. So in this case, all we have to do is to find r is add p plus j. Sometimes you might have to take negative p plus j. So they might have you, in order to solve one of these, you might have to reverse one of these vectors and then add the two vectors together. You'll see when we get over to here, to this one. All right. So here we go. To find r, we just have to add p plus j. So we know p goes down 1, 2, 3, 4, and it goes over 2. So p starts right here, and it adds 1, 2, 3, 4, and then over 2. So p, which I'm going to use as blue, goes from here to here. So this is vector p. Okay? Now, the resultant vector will go from where you started to where you ended. So it's going to go straight down here. So we started here, you walk to the down to the left, down to the right, and you ended right here. So this is vector r. And over here, you're supposed to figure out the length, which is pretty easy in this one. Since it's already aligned in a direction and not a diagonal, you can just count. So this is going to be 1, 2, 3, 4, 5, 6. So this is going to be 6 down. It's not negative or positive. The negative, again, is a direction, and we're just asking for the length, which would be 6. Some of these won't work out very cleanly. Okay, so for example, in this one, it worked out very well. But some of these, you're going to have to take vectors and then add them together and to find the length to do Pythagorean's theorem. Now the problem with some of these problems, like in this case, it doesn't tell you to find out this length right here. It's going to be difficult. But just like in the example that we just looked at, if we take the y and x direction components, which is what you need to do vector addition in this, since we don't know what this length is, we're going to take the y direction component, which is straight down, and add it to the other y component of vector p, which is right here. So this overall vector is going to be how many units down? 1, 2, 3, 4, 5, 6. So that resultant vector, which I'm going to use a different color, is going to be straight down 6. So this is a new vector, which is -6. Now the x direction vector, so j is going to go to the left, and then we're going to add it to p, which goes to the right. I'm going to use this guy right here, which is blue. And so by adding vector addition in one dimension, the overall resultant vector of this is 0. So this is y, this is r sub y is equal to 0, and r sub y is equal to -6, and this is r sub x, which is equal to 0. Now, to do Pythagorean's theorem, r squared is going to be equal to p squared plus j squared. Okay? So, to find, and I should use colors to denote those, start over. I could put this back to red. R squared is going to be equal to j squared, which is black, plus p squared. So r is going to be equal to the square root of j squared plus p squared. And if those lengths are already aligned to a y direction or an x direction, that's pretty easy to do. But on some of the other problems, they aren't aligned. You do have to separate out the y direction components of each, and then that will be your y direction, and then your x direction components. So the overall vector of this, which I showed you that already with the green, but we'll do it formally here, is going to be jx plus px, and we're going to have to square those guys. We're going to have to square root this entire thing. So that's going to be plus jy plus py. And we're going to have to square those components. So the overall vector is going to be this. So the x direction for p plus j we figured out is 0. So when we added those two x direction vectors, we got a vector which is 0. And we're going to square that 0. I know it sounds weird, squaring a 0. Plus the y direction components of negative j sub y minus negative p sub y is going to be -6. So those are, you just add those together, and we figured out that that was -6. So we're going to square this. So 0 squared is 0. So this is just going to be 36 inside that square root. So when we square the -6, we get 36. And so r is going to be equal to 6. Okay. So we're going to have to do that over here with these two guys. Okay. Now, excuse me. Let's do another problem. Okay. Now this one is a little bit more complicated, and you do have to think a little bit. All right. So I love these problems because they're kind of puzzle-like. Anyways. So in this problem, you're given this function u is going to be equal to, and I'm going to label this as 2z plus 3f. Okay? So what you're supposed to do is you're supposed to solve for f. All right? So in order to solve for f, we've got to subtract, to solve for f, we have to subtract the 2z onto the other side. So this is going to be 2, is going to be u minus 2z, because you've subtracted it from both sides, and that is equal to 3f. Now to solve for f individually, it is going to be u minus 2z, and we're going to have to divide that by 3, which is going to be equal to f. Okay, so start off, and by solving this, it kind of tells you the order. By solving for these this operation, it kind of tells you the order of what you need to do. So it's first saying we need to, so this is 1z. So this is 1z. Let's reverse 1z. So now that is -z. Now we're going to have to take 2 of those -z's and then add it to the u. Okay? So I don't know how much room I'm going to need, but here we go. I'm going to take u and I'm just going to redraw it over here. Now u goes over to the right 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5, 6. And it goes down to 1, 2. So this is u. And it looks right. It looks right. Yeah, it looks right. Sure, why not? Okay. Now z, -z, is pointed up and to the right 2, so which is -z, and then up and to the right 2 more. It's -z. Okay, so f goes from, well, no, hold on. So u minus 2z is equal to 3f. So 3f is going to go up and to the right this far, right? And so that is f. Well, actually, that is 3f. Because right here we said the addition of u minus 2z is equal to 3f. Okay? Now we could just take the components of 3f. So 3f's components is going to be equal to, well, how far over is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. That's going to be 10. Is equal to 10 there. So again, this is 3f. This is the component 3f's x direction component, and then we're going to add the y direction component, right? So we found out that 10 is, it's gone to the right 10 and up 2. Okay, now, and that should be, say, 3f right there. Plus 3f in the y direction. There we go. All right, so the way we did this other problem over here was a little bit drawn out. So it's easier just to do it this way. When you get your resultant vector, just take the components of the length of those resultant vector in the x and y direction. It is the same thing. So if we take the components of u sub x, which is right here, which is 1, 2, 3, 4, 5, 6. And then we take the components of negative z, zx, and add it to another zx. Well, you ultimately, this doesn't look too clean, so I'm going to do this. I'm just going to take zx and add it to another zx. Well, that distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the same length of this resultant vector. Similarly, if we take the components in the y direction, well, positive u goes down 2, negative z goes up 2, and then we have another negative z, which is up 2. So the overall resultant vector of this guy is, it starts here, goes down 2, up 2, and then you go up 2, which is just the y component of that 3f vector. Okay? Now, I'm sure there's a lot of ways to do this, but what I'm going to do, since I have this, is to find its length. We're gonna do so the length of 3f is going to be this. So we're going to take 3f, which we're going to call this, just think of this as a vector 3f. So we're going to square this, which is equal to 10 squared plus 2 squared. Okay, so that 3f resultant vector's length, okay, so the length of 3f, when we perform that operation and square root it, now we're finding the length of 3f, which is going to be equal to c squared plus a squared plus b squared. So this is going to be, what is that, 10 squared, which is 100, plus 2. So the length of 3f is going to be 100, that should be 4. Well, you know what? Leave that there. It should be 104, not 102, because 2 squared is not equal to 2, Jim. It's 4. Drive myself crazy. Okay, so square root of 104, square root of 104 is, I've already done it, 10.2. So 3f is equal to 10.2. Now the question is asking you to find the length of f. So we're going to take 10.2 and divide it by 3. I think this is the most efficient way to do this problem, these problems. So 10.2 divided by 3 is 3.4. So this is going to be 3.4. Okay. The vector addition of 3 vectors. Whew. Here we go. Now in this problem, so if you're in Physics 121, stay here. If you're in Physics 111, you could stop right here. Okay? Now, Physics 121 students, So you university physics students, here's what we're going to do. Again, you're going to perform the operation just like we learned, okay? And then we have to find the missing fourth vector, which is A, okay? And then you perform Pythagorean's theorem, and you're supposed to find the resultant angle between the overall horizontal and vertical components. Okay, in this problem, we're supposed to take, it's already set up. We're supposed to take A, and that's going to be equal to U plus B plus 2P. So let's go ahead and let's take U, and we're going to add it. So we're going to leave U as black. We're going to take B, and we're going to add that to U. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Is that 6? That looks like 6. 1, 2, 3, 4, 5, 6. So this is B. We don't have to reverse any vectors or any of that stuff. And then we're going to add 2 of the two of the P vectors to this. P is pointing down by 3 and over 2. So 1, 2, 3 over 2. So, oops, this should not be blue. We're going to use green. So P is going to be over 2. So 1, 2, and down 3. 1, 2, 3. And then we're going to do another P to that. So this is P, and then this is another P. So this is 2 of the P vectors. Okay, so the resultant vector goes from here to here, which is going to be this huge line, and that looks terrible. Oh boy, here we go. So this is down 1, 2, 3 over 2, 1, 2, 3 over 2. So this is looking like there. Okay, cool. So this is going to be A. This A vector has components, which is going to be 1, 2, so it ends right here. So in the y direction, AY is going to be equal to 1, 2, 3, 4, negative 4. I need more room. So that's negative 4. So AY is equal to negative 4. Now let's figure out what AX is. AX starts here and goes all the way over to here, right here, and that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So AX is equal to positive 16. Okay, let's find the length of A. So the length of A is going to be equal to, we're finding its length is A squared is equal to AX squared plus AY squared. So A is going to be equal to the square root of AX squared, which is 16 squared, plus what is that? Negative 4 squared. So that's going to be negative 4 that we're going to square. So A is going to be equal to, so 4 squared is 16. So let's do 16, and we're going to square it. We're going to add to that 16 equals, and then square root. 16.49. So 16.49. So that is the length of A, 0.49. for theta, well, we're supposed to take the components, the angle between the overall horizontal and vertical. So we've made a triangle, which is down 4 and over 16. So we could take this as theta or this as theta. Okay, so if we're the overall resultant between the horizontal and vertical, so since they're asking for the resultant theta, they want it between the horizontal and the vertical. So I think they're asking for this. So the answer could be either one of these. So we'll call this theta 1 or theta 2. All right. It doesn't matter, but the angle is not going to be 90 degrees. It's going to be one of these two things. So theta, let's do theta 1. Actually, let's do theta 2 because that's what you're used to. Now, theta 2, the tangent of theta 2 is going to be equal to the opposite side over the adjacent side. Now, I'm just going to caution you here, we don't care about the direction. We want the size of this. So a -4 is just going to be 4. So we want, is going to be, and we want to do this. We want to take the absolute value of opposite over adjacent. Okay, where the opposite in this case with theta 2, well, the side opposite that is 4, the adjacent side is 16. So this is going to be equal to -4, which is just 4 over 16. So so theta 2 is going to be equal to the inverse tangent of 4 over 16, which is going to be 1/4. So we're going to take the inverse tangent of 1 over 4. Okay. Make sure your calculator is set to degrees. So 0.25, and we're going to go here, we're going to take the inverse tangent of 0.25, which is equal to 14.04. So theta 2 is equal to 14.04. So 14.04. Now, the other side, which is theta 1, of theta 1 is going to be equal to opposite over adjacent. But in this case, opposite of theta 1 is this right here. Adjacent is physically touching theta 1. So in this case, adjacent side is -4. Okay, so opposite of theta 1 is going to be AY in this case. And the X component. So that is going to be equal to, opposite is going to be 16, and -4 absolute value is 4. So this is just going to be equal to 4. So theta 1 is going to be equal to the inverse tangent of 4. So let's figure out what that is. I'm going to type in 4 and do the inverse tangent of that. 4 inverse tangent, 75.96. So this is 75.96. 75.96. So the other possible answer is 75.96. You're supposed to do both. Okay? So this is how you do tutorial about addition and subtraction of 3 vectors in 2D. Okay? Well, that wraps up 2.0. Okay? 2.1 is coming next. Thank you. Have a good day.